scientists have taken another important step towards building the world's first bionic eye, which could give millions of blind people the chance to see again. In a world first, a team of researchers have built a three-dimensional artificial eyeball capable of detecting changes in light levels. The bionic eye, which mimics the function of the retina in order to restore sight, works in tandem with an implant to convert the images it sees into electrical impulses for the retinal cells, which carry image signals back to the brain. By using 3D printing, scientists were able to produce the prototype much faster than previous efforts, sparking hope this could be a viable commercial solution in future. However, there is no date on when a final version will be ready for patients. Researchers say, the next step is to create a prototype eyeball with more light receptors to recreate a greater quality of sight. They are also looking to find a way to 3D print the same technology onto a softer material, which could then be inserted into a real eye socket. University of Minnesota researchers created the artificial eyeball for the first time, using a 3D printer to add light receptors onto the hemispherical surface, which is half a sphere. It is the first step toward creating a bionic eye that could someday restore sight for blind, or partially sighted people. Bionic eyes could also be used to enhance the vision of sighted people. Bionic eyes are usually thought of as science fiction, but now we are closer than ever using a multimaterial 3D printer, said Michael McAlpine, a co-author of the study. Scientists had figured out how to print electronics onto a curved surface. They started with a hemispherical glass dome, according to the paper published in the journal Advanced Materials. Using their custom-built 3D printer, they lined it with a base ink of silver particles. The dispensed ink stayed in place and dried uniformly on the eyeball, instead of running down the curved surface. The researchers then used the dried ink to place photodiodes, which convert light into electricity, created using semiconducting polymer materials. In total, it takes around an hour to complete a bionic eye using this method. We have a long way to go to routinely print active electronics reliably, but our 3D printed semiconductors are now starting to show that they could potentially rival the efficiency of semiconducting devices fabricated in microfabrication facilities, said Dr. McAlpine. Highlighting another advantage of using the newly developed 3D printing method, Dr. McAlpine added, "Plus, we can easily print a semiconducting device on a curved surface, and they can't." For Dr. McAlpine, the interest in this field is also personal. "My mother is blind in one eye, and whenever I talk about my work, she says, 'When are you going to print me a bionic eye?'" he said. The University of Minnesota researchers say the next step in the process is to add more light receptors to the artificial eyeball, as well as find a softer, more forgiving material that could be used for a prototype that fits inside a real eye socket or orbit. This is not the first time these researchers have 3D printed bionic body parts. A few years ago, scientists produced a bionic ear, and since then they have 3D printed lifelike artificial organs for surgical practice. They have also made an electronic fabric that could serve as bionic skin.